Hello guys, let's talk about acid-base properties of salts. Actually, many ions react with water to create H plus or OH minus ions in hydrolysis reactions, so they can be acidic or basic. In order to determine whether a salt reacts as an acid or a base, we need to look at the cation and the anion separately. Now, let's say that you have an anion that is a conjugate base of a strong acid. Because it's a conjugate base of a strong acid, the base is going to be very, very weak to the point that this anion, which is a conjugate base, going to have a negligible tendency to produce OH minus ions from water, so it does not affect the pH of the solution. So it's going to be neutral. Similarly, when you have a cation, which is a conjugate acid of a strong base, it will not affect the pH of the solution because it's just simply going to be so weak that it is not going to form H plus ions in the solution. Now, on the other hand, if you form an anion as a conjugate base of a weak acid, the anion is going to be a weak base, so it's actually going to make the solution basic. On the other hand, when you produce cations that are weak acids, you are going to have acidic solutions. And that is going to happen in case of transition and post-transition metal cations and in case of polyatomic cations containing one or more protons. So this makes sense because most strong bases are alkali hydroxides. So those are from group 1 and 2. So if you have transition or post-transition metal cations or polyatomic cations, those are going to be formed from weak bases. All right, so let's take a look at the summary slide right here. If you have a salt formed from a strong base and a strong acid, you are going to have that salt as a neutral compound. So basically, when you have group 1 or 2 metal cations with an anion of a strong acid. On the other hand, when you have a group 1 or 2 metal cation with the anion of a weak base, your salt is going to be basic just like the anion. On the other hand, when you have transition or post-transition metal cations or polyatomic cations, which are formed from weak bases with an anion of a strong acid, you are going to have acidic salts just like the cations, right? Because those are actually formed from weak bases. Now, when you have post-transition or transition metal cations or polyatomic cations with an anion of a weak acid, we will have to compare the acid dissociation constant and the base dissociation constant to figure out whether the salt is acidic or basic. All right, just to remember, I have all the strong acids and most strong bases right here given. Let's take a look at the practice question. Let's predict whether the pH of each of the following salts placed in water is acidic, basic, or neutral. So we start with sodium chloride, and first I'm going to look at the positively charged part, so at the cation. Here I have an Na plus or sodium ion, right? And I know that this is actually a group 1 metal cation. I can take a look at the periodic table. It is indeed in group number 1. So I start right here, either option 1 or 2, and then I take a look at the anion, the chloride ion, Cl minus. Is it formed from a strong acid or a weak acid? I have all the 7 strong acids given here. Do I have hydrochloric acid in that list? Yes, I do. It's right here, right? So this means that NaCl is formed from a strong base and a strong acid, so it's going to have a neutral pH, when it dissolved in water. What about ammonium bromide, NH4 plus first? So is it a group 1,2 metal or something else? It's something else, right? It's actually a polyatomic cation. So we are looking at options 3 or 4. Now, what is the bromide ion, Br minus? Is it an ion formed from a strong acid? Yes, it is. It's formed from HBr, hydrobromic acid. So here we are going to have a polyatomic cation with a strong acid's anion. So overall, our salt is going to be acidic, just like the cation, the NH4 plus. What about the next example, potassium nitrate, KNO3? Well, K plus is actually going to be a cation from group 1. What about NO3 minus, the nitrate ion? Is it formed from a strong acid or from a weak acid? From a strong acid, right? It's actually also in our list. So again, we are going to have a neutral salt because we have potassium ions, which are formed from strong bases, and nitrate ions, which are formed from strong acids. Okay, let's move on. We have the next one, potassium chloride. So we know that potassium is again going to be K plus, a group 1 metal cation, and ClO2 or the chloride ion is actually going to be formed from a weak acid. It is not in our list right here. So in that case, we are going to have a basic salt, just like the anion, the ClO2 minus. What about barium chlorate? BaClO3 2 times. So barium is actually a group 2 cation. So we are down again to option 1 and 2. And what about ClO3 minus or the chlorate ion? Is it formed from a strong acid or from a weak acid? From a strong acid, right? It's right here. So again, we are going to have a neutral solution. Now, what about aluminum perchlorate? Well, aluminum is definitely not in group 1 or 2. It's actually right here. It has a charge of 3 plus, and ClO4 minus is actually formed from a strong acid. So in this case, you are going to have a post-transition metal cation with a strong acid's anion, so our solution is going to be acidic. Now, the last option is ammonium cyanide, NH4CN. So in this case, we actually have a polyatomic cation, NH4 plus, with Cn minus, the cyanide ion, which is formed from a weak acid. So here we need to look at the acid dissociation constant and the base dissociation constant in order to be able to figure out whether this is acidic or basic. So we know that NH4 plus or ammonium cation is formed from NH3, right? So NH3 is the conjugate base of NH4 plus. And we know that the cyanide ion, the Cn minus ion, is actually formed from HCN, hydrogen cyanide. HCN is the acid and Cn minus is its conjugate base. Now you can see from the K sub B and K sub A values that actually NH3 is going to be a stronger base than the strength of HCN acid, right? Because simply the value for K sub B is larger than the value for K sub A in case of HCN. So from here, if NH3 is a stronger base, we can say that the conjugate acid that it formed, so K sub A, is going to be weaker. And the K sub B for Cn minus should be in this case larger than the K sub A for NH4 plus. All right, I hope this makes sense. So basically, from the stronger conjugate acid, you are going to form the weakest bases. From the stronger conjugate bases, you are going to form the weakest acid. So because the conjugate base is stronger because its K sub B is larger than the K sub A for the acid, we are going to end up with a basic solution for NH4CN or ammonium cyanide. All right, I hope this makes sense. See you in the next video.